Hi everyone. So this time around we're going to be looking at doing an assembly of our parts that we made in the previous video, and we'll also be looking at doing technical drawings of the assembly and the parts as well. So those can be seen in these tabs here. We'll wait for them to load. But yeah, these are really industry standard skills that you'll need to learn how to do if you're at all interested in the industry or anything related as such. It's a really good skill to learn. I've recently used it to design a floor layout for a kind of like a living area. And it's really helpful because not just the drawing, but the assembly and the part studio. But it's really helpful because it allows you to visualize things that you would otherwise have to kind of guess. And you can get really accurate dimensions and everything like that, yeah, you just otherwise wouldn't be able to get with purely your imagination. And sometimes drawing can be a bit bleeding, while when you're getting parts and you're giving them dimensions and putting them in rooms that you've measured and things like that, it becomes really quite apparent where things sit and how far away things sit from other things. And yeah, same thing with any object. Really good to be able to model things on here. Great for 3D printing, all kinds of things. Great skill to be able to have just in general. This is the assembly here that we'll be doing in the video, and these are the drawings. That's the drawing of the assembly, technical drawing of the assembly. This is not AS1100 template, although it's similar but not quite the same thing. These are the uprights. The diagonal uprights of the arbor, the triangular arbor. And finally this is the base and a little rod that I did in the video in order to fix the uprights to the holes here that are in the base. So yeah, really good skills to know how to do, and we'll go through them now. Alright, so now we'll do an assembly. So we've got all our parts in our part studio, and you'll always have this default blank template that pops up called assembly 1 usually, and that's where we'll do our assembly. So go to our front view, use the insert tool, and straight away we'll just put our base in, and then we'll left click on that one or double click in the middle of yours like mine, and we'll fix that. That's going to be our reference point for everything. And then we'll put our male upright in. Click, and click tick on that. And we'll do our fastened, we'll do our planar mate first. So if you just come around here, select, we'll go to planar mate. And so what you're going to do when you select a particular face, see this little bullseye thing with the green and red line and then also a blue line attached to it. You're going to want that to be in the center of whatever face or hole or whatever that you're selecting to face up. So you don't want it on the corners or the edges here, we want it in the center. So that there, and then we're going to come around here. I'm going to select the same thing on the other side. So, alright, now that's, I'll get a better view. So that's up against there now. Alright, so tick that. And now there should still be a degree of freedom. If we grab this object, we can still move it along that axis. It's always going to remain in line with it, that plane. But yeah, as you can see, it's just sliding in and out. But yeah, we Still need to constrain it further. So we're going to zoom right in to this hole. I'm going to select that bullseye, make sure it's at the front of the hole, which that one is. Left click, and then we're going to face it up and face it up to that hole there. Alright. And then tick. Now we'll see if you press play here, it should animate the degree of freedom. So I've pressed play and it doesn't have any degree of freedom, and when I click it and try and drag it, so there is 1 degree of freedom somehow. Yeah, so it's in line, it's facing up against that side of the hole, it's in line with that mate. We just need to constrain it so that it doesn't have the in and out of kind of that direction of freedom. It can't go side to side. As you can see, I'm trying to move it left to right, but it's only going in and out. So in order to restrain that further, I will use, I believe, a pin slot mate. Let's try and do a planar mate on this edge. So selecting that there with the bullseye on the line, and then we're going to select that there with the bullseye on that line. And as you can see, it didn't really go in the right position, but I think it's just a bit glitchy when you match things up. So where's my mic? Well, I hope you've been able to hear what I've been saying. But yeah, that should be alright if we press tick on that. And then also we're going to need to bring that face down to our... Oh, that might have stuffed things around actually, so I might Control Z that one. Let's try the pin slot then. Pin slot. Select the bullseye. And select that bullseye and then tick. Still has that degree of freedom. Go back. Pin slot. Select that one. Tick. Let's see what the new degree of freedom is. Still just those bits. Then we'll go this one. And then select that one. And tick. See if it's still there. I expect it's still going to be there. So just going back to our part studio, see how things kind of matched up here. Might have to create a little dowel that goes through in our part studio. I'll do that now, just quickly. So we know that the thickness of that is 150 altogether. So I'll just make a new part actually. Create part studio. So just gonna really quickly create a circle, and it was 12.5 millimeters diameter. And okay, extrude it. That 150, sorry. And cool. Alright, that's our new part. Right, we'll try and use that as our restraining vector. So we'll insert new part, part studio 2, and there it is. Tick that, and go over to it. Now, I'm going to go with pin slot. Go to that face, and that face there, and click OK. Now, let's see if that still has that degree of freedom. So it does. We can do the same thing. Perhaps a cylindrical mate will be better in this situation. Yeah. And then okay. Oh, still has that degree of freedom. Like that cylinder. That there. That's solve. And then we're going to do the same thing for this hole and this hole. Solve. Okay, now that should do it. Sorry about that. There we go. No degree of freedom. Lovely. So we'll just do one for now, and we'll do the other parts. Okay, now we can click X on that. We'll see what the remaining degree of freedom is with that particular part. No degree of freedom there. No degree of freedom there. No degree of freedom there. Say it has a rotational degree of freedom. Let's go to 0 degrees. 90 degrees. That's fine. It can rotate. It's not an issue for us. But yeah, we know our degrees of freedom now. Alright, now we'll insert our female part from this part studio. Oh. Go into just Control Z those two parts. Female. There we go. Alright, now you can tick on that. Now we use our planar mate. And we'll go that there. So we won't go that there. We'll go X that one. We'll go this one here and here. That there. So bullseye's on that middle of that face. And then we'll go to that face there. And tick that. Now it should still have a degree of freedom to it. That's alright. We will go with Let's try this corner. That corner. And solve. Now let's see if we have a degree of freedom there. Yeah, I still have that degree of freedom. Might just have to fix it there because we know it's perfectly kind of up against that part. Go right and zoom right in. Yeah, it's in line and everything. So I might just have to fix it where it is. Not really sure how to get around it. So okay, left click on that object and click fix. So now it doesn't have a degree of freedom. Alright, now we're going to do the same thing with this one on that side. So insert, down arrow instead of clicking on the whole thing, and a new base. Planar mate that part. Zoom right in, make sure you're grabbing the right one. And then that face there. And then tick. And then just we'll move this bit out. And we'll use our pin slot to insert. We will use our cylindrical mate on that. Okay. And then the same thing for the other hole. Make sure we get the right one. Oh. Okay. And just putting that face as a planar mate up against that face. Solve that. Oh, didn't quite work. Oh, I think we've centered it accidentally. So wrong face we used. Alright, now cylindrical mate up against that face there. Solve. Lovely. Alright, now we can see what our degree of freedom is. Anything. Alright, so that's our assembly done. Cool. We could probably put some more of the rods in. We'll just do that. I might just leave it. It's not really necessary unless I was to put this into a drawing, which I will actually. Alright, we'll go through and we'll do that. Go through the effort. Insert. We want another 6 of those rods. So 1, 2, 3, 1, 2, 3. Alright, tick. And I'll go through. Go planar mate. Select 2 holes, tick. Planar mate, hole, tick. Planar mate, hole, tick. hide our male upright. Oh, what happened there? Yep. And select our cylindrical mate. Oh, wrong one. And hide our male. Select our cylinder. That, and then show our male and hide our base. And select that face. And tick. And then show our base again. And then repeat that process, but as long as it's in there, it's not really necessary. So planar mate, that, solve, that, good, and that, done. Alright, now we have our whole assembly done. Okay, the next thing we can do is we can put it all in a drawing. So click out of that, show that, and we'll make it a drawing. And there's default ones in here. I think the one I just choose at the moment is ANSI B millimeters, or I may have opened one. No. So have I recently opened one? No, it's still on public. So an A3, go on shape maybe. Alright, A3, go ice, try this one. Okay. And we can put our assembly in. Scale can be 1 to 30, 1 to 20. 1 to 20, there we go. We'll do a front view. Side view. And a isometric. And I'll just move these around down here. And we'll put in some critical dimensions. Almost want it a bit bigger, don't we? Try change our scale to 10. A bit too big. 1 to 15 maybe. 16. Get out of that. Select our previous ones. Might have to delete the initials. Alright. So view 1 to 16 is what we're going with. Front view. So assembly 1. A front view. Side view. And a isometric. Alright, now let's put in some critical dimensions. There we go. From here, so left click on the top point to the bottom corner. And now we want that to be a different type. Maybe I have to go back on that one. I was more thinking of a different dimension. Go that top bit. This bit here. It's the same. Trying to get this dimension here, which is probably all I need to do is this, isn't it? There we go. It's not a round number, but that's okay. This part. There's a few non-round numbers, is there? 16. 60. And then 50. And then that dimension there. And that dimension there. Put it. And that means we'll just have to move a few of the dimensions out. Move that one further. Move that one so it's in line with that one. Move that one so the 60's on this side. further out as well, and move the 200 so it's in line. And it's on the other side. There we go. And then this can come out further as well. Okay, so we've got some critical dimensions up here. Probably need to know that dimension there. Between those two. Lovely. 45. Can bring that out further. And then they can choose whatever angles they want. That's fine. So the critical dimensions are there for that part. We're going to have to do some on the blocks. We'll do these circles. There we go. 12.5. And then, when you have multiple of the same hole, you want to write times the amount of holes that you have. So we have 8 holes, so we're going to go to our note feature, and we're going to write times 8. And that's it. Simple. And we can get out of that feature now. We got to put the dimension in for this bottom dimension. For the side. Oh, actually, no, we don't need to do the side height. What else do we need to do? This dimension here. And that one takes control of the height dimension of both of those. Oh, distance in from the side. That and that. So when you do distance from a side, you left click on the face and then you left click and shift on the next face that you want to do the distance between. I don't know if I made that myself clear before on that. Yeah, so 10 mil, go 10 mil either side just for good measure. 10 mil. And then in terms of positioning for where this sits in relation to the stand, that will all be worked out when we do the individual part dimensioning, which is good. Alright, so now let's do high dimensions on here. 50, 80, 50. And length dimension 950. Dimension of between here and here 50. And then the dimension between here and the bottom, the top and the bottom. It's an important dimension. Again, not exact numbers, which isn't ideal, but what happens when you're dealing with angles and things like that. That should be all the critical dimensions for that part. Is it all clear in here? And that's probably better off over there actually, because the line, it's deceptive. It looks like it's from that joint, but it's really from this point here, which is where the 50 is. So we'll bring that over here. And we'll bring him further out. It should be alright like that. Yeah. Right, looks good. Right, now we'll fill in this table here. Automatically does the date, automatically puts your account name in. You can also just change it if you need, just double click on it. Checked, usually by the person you're submitting it to. You can send drafts off to whoever in industry. You send it to your boss or the client, and then approved by typically your boss. But we'll just write Jordan Peters once again. And then you usually print it out and do signatures, handwritten and everything like that. Otherwise you can do it on digital. And then date at which your boss or the client checked it. We'll just do today. Pretend we send it off all in one day. What's the date today? The 12th. 12th of the 10th, isn't it? October of 2021. Oh. Bit of a different convention for the date. /20, 21. That's how we do dates. 12/10, 20, 21. Enter material. Let's write hardwood on that. It's a variety of materials. Finish unknown up to the person. Then you write your title. I'm going to write Triangular Arbour. And usually you write whatever course or maybe the particular company that you work for in this top section, or maybe it's a part of a larger set of drawings. And you usually put that in the top section there. So this is drawing number 1, revision 1. And sheet 1 of 2, maybe even 3. We'll do 3. And weight relevant, scale, size all done for you. Don't need this, that's for metal. Surface finish. This one I'm going to write Jordan and Co. Dot. That's my company that I work for. Put that there. Then with these weird quadrant things, I like to delete them out. You can... Oh, you can select this prior and do it properly the first time, but I'm just going to delete those out. I just like a clean border. We select multiple. Nearly done. Alright, I believe that's done. I can delete those lines, those extra lines out. And we will move on to creating the next drawing. Same thing as what we did before. We might do third angle projection. I don't know what the go is, but that should be third angle, I'd say. Yeah, third angle projection. There we go. So we're going to try and use the same scale, ideally. So 1 to 16. There we go. That looks like it's the same. And I believe we only need that kind of front view. That should be enough. Now insert view, Part Studio 1. Get the female in there as well. And we'll do it over here. Alright. Let's work on these dimensioning. Go through. Now, because the parts are obviously separate, we're just going to write ×4 on this one because they're not technically connected like they were in the assembly. So we're just going to go ×4 for that particular part and click out. Now, here's where it gets interesting. We're going to dimension how far things are away from each other and from the corner here. So we're going to figure out that that's the center of this is 40 mil from the center of that across. So left click on the middle dot, and then hold shift and left click there. And then as you can see, it says 40. And pull that across. Then left click the middle and then left click the whole edge, and that's because it's our 30mm dimension. We'll pull that out further probably. There you go. Yep. Back to our dimensioning tool, and then between the two dots is another 30. And then between these two top ones is 50. So holding shift, trying to find that second dot. I don't know what's going on. There we go. 50. All right. So that should be all the critical dimensions we need in terms of that. So it's 40 across, 30 up, 30 up, 50 across, 30 down, 30 down. We know all that. Cool. And now we want to dimension this bottom bit, 105.41. And we will dimension the thickness, holding shift. And then we gotta dimension this whole length. See, that's the number that I was looking for before that wasn't coming up. Might want to move it a bit further in. I'll do the same on that one. So I might go back to the last drawing and delete that dimension out because it's misleading. So delete that. There we go. It's obviously to a different point. Alright, so we also probably want to get this inside dimension. This will be probably an odd number. Yeah. There's a lot of crossing over of lines here, which is not ideal, but can't really help it in this situation. Okay, now can work on these dimensions here. 60. I kind of already did this in the other. Put it up the top maybe. 60 between those 2 points. 50. 200. And then 66. 2, 3. In other words, whatever's left essentially. There we go. Then the distance between there and there. All right. That looks like it's all good. I can do the same on this. Right. Keeping things in line is always useful. Sometimes, obviously, like in that situation, there'd just be too many arrows. Lose track of where things are. Yeah. Let's do one just straight here and there. All the way down here. And same thing there and there. 100. And between here. Okay, now probably need to move these a bit further away from each other. A bit further up as well. Alright, that's better. Okay. Same thing over here. Dimension all of those points. Oh, that's the wrong one. It's going to be the outside one. And then just the, I've got to move that note again. Grab that one as well. We'll see. Put it over here. And we'll dimension the holes. Don't want that, I want that. There we go. Yeah, it looks good. All right. There we go. Looks pretty good. Might want to move or center all of it. We'll move it all in one big go. And grab the notes as well this time. Alright, looks good. Delete out those sections. A lot of dimensions going on. Alright. So I'll change the date to the 12/10/2021. And I'll leave, we'll do it just to solidify it. Jordan Peters. Jordan Peters. Delete that out. And 12. Wait, what? Yeah, it's the 12th. /2021. 12/10. That seems to have corrected itself. There you go. Material is hardwood. Remove that. Jordan and Co. And it is the Arbour Triangular. Oh. Alright, Triangular Arbour. And then specifically, it is the upright male and female parts. And then drawing number one, revision 1, and sheet 1, 2 of 3. The scales there, size A3. Then that's about it, I think. Good. Alright, now one more drawing. It's a fairly simple part, so. Select our scale, go to our part studio, and we'll put our base in. Now, first view will be a front view, then a side view, maybe a top view. Front view and a side view should suffice. And then we'll set our rod as well. Insert That's GO2, that's where it is. And we'll put in the front view and the side view. There we go. Alright. Let's dimension these. 12.5mm rod. And the length is 150. And that's really all the dimensions you need. Now this one is 950 long. Is the distance between this part and this part is 50. And the distance of the part is 50. And what else can we do here without doing too much? I think that's all we need to do. Well, I might do that dimension there, 50. Oh yes, and that dimension between there and there being 400, that's an important dimension. 400. So 150, and then make up the difference. Go that dimension there. 80. And yeah, then we can do a few more things on here. So 12.5mm hole. I'm going to times that by 4 later. I'm going to times that by 8 actually. Bring that out. This dimension here. 130. Got our height dimension there. Need this width dimension. 150. And we need that shoulder dimension, so holding shift. 10mm. Yeah, and then we'll obviously need to do our distancing and everything. Between points. So 30mm between that point there. And then 40mm between that and the side point. Bring it up here. And then 30mm between the two center lines of the holes. And then last but not least, 50mm between these two center lines. Lovely. Might want to change the scale on this one actually. It's good to keep the scale consistent, but maybe we need to change it. Let me change it from here. No, we don't want to do it like that. We select all of this. Change scale. I need to look it up again. 1, 2, 2. Let's try this. Right click, view properties, and it's 1 to 16. We'll go 1 to 8. There we go. That's the way to do it. Go 1, 2, 4. Yeah, that's the go. I need to move this one now. It's nearly the size of the whole thing. Maybe you might reduce that actually. So otherwise it won't fit. Yeah, 1, 2, 6. I'll put this fella down here. And well, it looks like it's changed one but not the other. View properties, 1 to 6. There we go. Alright, now we can move that a bit closer. Move this guy in. Move this one way down here up. Don't need that scale button, we can just write it down there when we get a chance. Alright, now, is that everything's still in its necessary place? Move that out further. Looks good. Move that up higher. And do a note here. Times 8. Both sides. That needs to be, yeah, like that. Change the scale of these ones too. Properties, change them to 1:6. Okay. Alright, now we can focus on this part of it. So 1:6, alright. That's how, I guess that's just good to know that you don't always have to commit to something that you've done previously in the drawing. You can always kind of change things later. Ideally, you always get it right the first time, but you know, sometimes it doesn't always work like that. Alright, we're nearly done now. And draw, delete that. Hardwood / Tasmanian oak. The dowel joint is Tasmanian oak. Title is, what do we call it? Our Triangular Arbour. Parts. B base. B base and dowel. Tick. Number 1. Vision 1. And this is 3 of 3. And then we'll write our note up here. Jordan and Co. Dot. It's actually pretty centered. There we go. Alright, then delete our little quadrant things out. Make that an A3. So we need 2 of these parts and then 1 of these parts. Base times 2. Increase the font size to probably something like 6. copied. That one. Now we need 8 of those. Alright, and I believe we're done. So that is start to finish the process of building, drawing in Part Studio, then doing an assembly, and then doing technical drawings of your assembly and parts. So I hope you enjoyed the process, and we'll see you next time. All right.